Welcome, ladies and gentlemen. This is lesson 2 in your exponents unit. We're going to be simplifying expressions involving exponents using the power rule. So what does the power rule state? The power rule states that when we raise a power to another power, we can multiply the exponents. So what you're going to be noticing today is when there is an exponent right outside of the parentheses, what can we do to get rid of those parentheses and simplify our expressions? So in this first example, we have 2 cubed raised to the power of 2, all raised to the power of 2. So when there's an exponent right outside the parentheses, what can you do? You can multiply your exponents. So if we think about what this means, it means 2 cubed squared. What does 2 cubed look like? 2 times 2 times 2. So we're going to take that and we're going to square it. So 2 times 2 times 2 times 2 times 2 times 2. Well, how many 2's are we multiplying by itself? 6. So there's how we get where we multiply our exponents. 3 times 2 is 6. That's the same thing as 2 to the power of 6. So what does that look like when we involve variables? Well, we can do the same thing. Okay, x squared raised to the power of 4. I multiply my exponents. 4 times 2 is 8. So x to the power of 2 times 4 is x to the power of 8. So let's look at what that looks like when we break it out in factor form. So x squared looks like this, x times x. How many of those am I multiplying by itself? 4. Okay, there's 2 groups. There's a third group. There's a fourth group. And we're multiplying all these by itself. How many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we can actually use the product rule. X to the first power raised to the first power times x raised to the first power times x raised to the first power, and I can add all of my exponents to get x to the power of 8. So I can actually use the product rule, which we learned about yesterday, to prove the power rule. Okay, so let's get started on all of these examples. Simplify each expression using the product rule where we're going to multiply our exponents. So number 1, what is that going to be? X to the power of 3 times 6 is x to the power of, x to the power of 18. That's it. That's your answer. What about number 2? Y squared raised to the power of 10. Again, we're looking at that exponent right outside these parentheses. How do I get rid of those parentheses? I multiply my exponents. Y to the power of 20. What about number 3? What is that going to look like? M to the power of 2 times 5, which is 10. All right, let's go to the next little section, or row, I should say. So number 4, how is number 4 different than questions 1, 2, and 3? I have a number inside my parentheses. So today, what we're really looking at is we have an exponent right outside these parentheses, okay? Every single number and variable inside the parentheses is getting raised to the power of 2. What you have done with your numbers is what you do with your numbers here is what you've always done with your numbers. So the first thing I'm going to do is raise this 5 here to the power of 2. Well, what is 5 squared? It's 25. So I really like off to the side to write out my numbers off to the side. That's a really helpful strategy. So 5 squared is 25. But what can I do with my exponents? That's what we're introducing today. I can multiply them. So 5 squared is 25. And then what can I do with my exponents? Multiply them. 3 times 2 is 6. On number 5, we notice there's a number inside my parentheses and an exponent, or a power, right outside my parentheses. So we're going to use the power rule. Again, what we do with our numbers is what we've always done with our numbers. I'm raising negative 3 to the power of 2. Well, what is negative 3 squared? Positive 9. Notice I wrote this negative 3 inside the parentheses. If you wrote it like this, that's actually negative 9, and that is not correct for this problem. I'm taking negative 3, which is inside my parentheses, and I'm raising it to the power of 2. That's negative 3 times negative 3. That's positive 9. Especially if you're using a calculator, it's really important that you get that right. Because if you type it in just like this in your calculator, you get positive 9. Okay, so negative 3 squared is 9. Now, if I don't have an exponent there, what can I write there? I can write a 1. What do I do with my exponents? I use the power rule. I multiply my exponents. So this 2 is going to be multiplied by that exponent. This 2 is also going to be multiplied by that exponent. So this becomes x squared y to the 4th. So in this unit, I like to say numbers, then variables. Let's look at the numbers first, and then let's look at each variable at a time. Okay, number 6. Ooh, don't let this trick you. Negative, if nothing is in front of those parentheses, what can I put there? Negative 1. Okay. All right, so let's see. The first thing I noticed in number 6 is I have an exponent right outside the parentheses. So I'm going to be using the power rule to simplify this. The first thing I'm going to do is raise 4 to the power of 3. So off to the side, 4 to the power of 3. What is that? That's 4 times 4 times 4. That's 64. So I get 64. And then I raise each variable, and this exponent is also raised to the power of 3. What can I do with my exponents using the power rule? Multiply them. So 2 times 3 is 6. 5 times 3 is 15. Now don't forget, I have this negative 1 out in front. What does that mean? It means negative 1 times all of this. Negative 1 times all of that is negative 64. X to the power of 6, y to the power of 15. Okay, let's go on to number 7. Number 7. Okay, lots going on here. I have a 4 times whatever this is. If I think about my order of operations, PEMDAS, I need to apply this exponent before I do any kind of multiplication, because that 4 outside the parentheses, that means I multiply. And my order of operations tells me I need to simplify my exponents first. So that's what we're going to do. We're going to use the power rule. Again, I have a number inside my parentheses. Okay, what is 1/2 to the power of 4? That's 1/2 times 1/2 times 1/2 times 1/2. You can always plug it in your calculator, or you can multiply. When you multiply fractions, multiply across. You get 1/16. Okay, so I get 1/16. And now what can I do with my variables and their exponents? I use the power rule. I multiply. So 2 times 4 is, you know what, I really don't like it when I do that. These variables don't go in the denominator of this fraction, so I like to put it right there in the middle. X to the power of 8, y to the power of, what's 4 times 4? 16. Z to the power of, what's 3 times 4? 12. So don't forget, we're multiplying all of this times this 4 out in front. So now when I'm multiplying by this 4, what is it affecting? Is it affecting any of these variables? No, it's only going to affect the number. So 4 times 1/16 is what? It's 1/4. Because 4/16 simplifies to 1/4. So 1/4 x to the power of 8, y to the power of 16, z to the power of 12. Okay, let's go on to number 8. What do we have going on here? Well, we have this monomial raised to this exponent times this monomial raised to this exponent. Okay, well, I need to simplify my exponents before I can do any multiplication, so let's do that. This -2 is being raised to the power of 3. I like to write that off to the side. -2 times -2 times -2 is -8. And then now what can I do with my variables and their exponents? Well, a to the power of 2 times 3 is a to the power of 6. B to the power of 5 times 3 is b to the power of 15. Times, now let's look at this second monomial. I've first thing I'm doing is I'm raising 3 to the power of 2. So off to the side, 3 to the power of 2 is 9. And then if I don't have an exponent with these variables, can I put one there? Sure, I can put a 1 there. And then I multiply. I apply the power rule. A to the power of 1 times 2 is 2. B to the power of 1 times 2 is 2. Now some of you might not want to do that, and that's totally fine. You don't have to. But now, in number 8, I'm not done. I can continue to simplify. But what would I do to simplify? I would use the product rule. Now I'm multiplying. And what does the product rule tell me that I can do with my variables and their exponents? I can add them. So the first thing I do, and I'm going to change colors here, is I look at my numbers. -8 times 9 is -72. Again, what we've done with our numbers, or what we do with our numbers is what we've always done with our numbers. Then I look at each variable at a time. A to the power of 6 times a squared, add them. A to the power of 8. B to the power of 15 times b to the power of 2, add them. B to the power of 17, and that's your answer. Okay, let's go on to number 9. Number 9, this is the same type of problem. I've got this monomial raised to this exponent, and this monomial raised to this exponent, and then I'm going to multiply whatever that is, or whatever those are. So again, order of operations. I have to simplify these exponents before I can multiply. I need to know what this is. What does this represent? What's the amount simplified? Okay, so the first thing I'm going to do is raise this number to the power of 4. So what is 4 to the power of 4? 4 times 4 times 4 times 4, that's 256. So let's write that down. Then what can I do with my variables and their exponents? I multiply them. So this becomes m to the power of 4, n to the power of 4 times, and now I'm looking at the second monomial, 0.5 raised to the power of 2. What is 0.5 raised to the power of 2? 1/2 times 1/2? It's 1/4, or 0.25 is a decimal. 0.25, and then m to the power of 2, using that product rule. Using the power rule. And now we're going to go back to the product rule. So I'm multiplying numbers, then variables. I'm going to multiply these numbers first. So what is 256 times 0.25, or 1/4? What's 1/4 of 256? 64. And then my product rule tells me I can do what with my variables and their exponents? Add them. M to the power of 4 plus 2 is m to the power of 6. And then just because I don't have an n over here doesn't mean this n to the 4th goes away. I just bring it down. N to the power of 4. Let's go to number 10. It gets a little tricky when you start combining all of these exponent rules. Okay, there's a lot going on with number 10. I've got 3 monomials that I'm multiplying together. Okay, but first, what do I need to do? I see that I have exponents right outside of these parentheses. This 4, this 2, and this 3. I have to simplify those first. I'm going to use the power rule. So this first one becomes x to the power of 8 times. Now in this next one, what am I going to do? Numbers first. -3 to the power of 2 is what? +9. And then I apply my power rule. X to the power of what? 4. Y to the power of 2. Times. The next one, I've got to raise this number to the power of 3 first. 2 to the power of 3. What is that? It's 8. Then what can I do with my variable and this exponent? Multiply. Y to the power of 6. And now we're back where we were yesterday, where we can use our product rule. Because we're multiplying. What do we do with our exponents when we're multiplying? We add them. Okay, so first thing, I'm going to do my numbers. So I can always put a 1 there if nothing is in front of my variable. And then I'm going to multiply all of the numbers together. So 1 times 9 times 8, 72. And then what can I do with these variables and their exponents? I add them. So 8 plus 4, I'm looking at each variable at a time. So x, then y. 8 plus 4 is 12. And then y to the power of 2 plus 6 is 8. And that's my answer. Let's go on to number 11. Ooh, what does number 11 have that none of these other ones have? A plus sign. So now I'm adding yet another rule. I'm going to be combining like terms if and only if they're like terms. Okay, so I see a lot of stuff going on. The first thing I notice that I see these variables, or I'm sorry, these exponents right outside these parentheses. I need to simplify those first. So the first thing I'm going to do is just rewrite this 2mn cubed times, and then 4 raised to the power of 3 is what? 64. Then each variable at a time. M to the power of what? 3 times n to the power of 3. And then still following my order of operations, I'm going to multiply these before I add it. You know what? I didn't simplify this one over here. So let me simplify this one over here. Negative 5 raised to the power of 2 is what? Positive 25. Then I can apply my power rule. M to the power of 4, n to the power of 6. I've multiplied those exponents. So now at this point, still following my order of operations, I'm going to multiply before I do any kind of adding. So when I multiply, numbers first. 2 times 64 is 128. And then I simplify using the product rule, one variable at a time. So m times m cubed is m to the power of 4. Then n cubed times n cubed is n to the power of 6 plus, and what do you know? We do have like terms. In fact, when I've got a problem like this, and I don't end up getting like terms, which I look right here, n to the power of 4 times n to the power of 6, n to the power of 4 times n to the power of 6. If they're like terms, then I can combine them. If I don't get like terms, I'm like, did I do something wrong? Let me go back and check. So because they're like terms, I can combine them. I combine them by combining their coefficients. 128 plus 25 is 153. Last name stays the same, as I like to say, or variables and their exponents stay the same. Okay, going on to the last one. Okay, so lots of stuff going on here. We've got powers to powers, so I need to apply the power rule. We're multiplying, so I need to apply the product rule, and then we're adding. So if they're like terms, then I can combine them. Okay. Order of operations tells me I simplify my exponents first. So 2 raised to the power of 2 is 4, and then I apply my power rule. X squared raised to the power of 2 is x to the 4th. Y raised to the power of 2 is y squared. Times, what's this next monomial raised to the power of 2 going to be? X squared, y squared. Plus, over here, let's go ahead and simplify these. Let's get rid of these exponents. That's kind of what we're doing. It's like going back to the distributive property. Remember that when you have a number in front of your parentheses, how do you get rid of those parentheses? You distribute it to every term on the inside. Well, here it's kind of reminiscent of that, right? We're distributing this 2 into every single number and variable on the inside of my parentheses to get rid of those. All right, so 4 squared is 16. Then I can multiply my exponents. So 3 times 2 is 6. And then y squared times y squared. Okay, because I didn't have an exponent outside my parentheses here, so I didn't have to do anything. I just dropped the parentheses. So now, order of operations tells me I need to do these multiplications before I can do the addition. So if I don't have any number in front of my variables, I can put a 1 there. And I multiply my numbers first. 4 times 1 is 4. And then I can apply my product rule. 4 plus 2 is 6. So what did I do there? I looked at just the x's first, one variable at a time. Now let's go to the y's. 2 plus 2 is 4. I just looked at the y's. Plus, so now moving on to this next part over here, I can put a 1 in front of that y squared if nothing is there, and then 16 times 1 is 16. And then what can I do with my variables and their exponents? Add them. Well, this x to the power of 6 I'm not multiplying it by anything, so I just bring it down. It doesn't go away. I don't know why my screen is doing that. And then y squared times y squared is y to the 4th. And then now, do I have like terms? I do. So because I have like terms here, I can combine the coefficients. 4 plus 16 is 20. Last name stays the same. X to the power of 6, y to the power of 4. I don't know why my screen is doing that. But that concludes your notes over using the power rule to simplify expressions involving exponents. I hope it was helpful.